Hi, welcome back to Mrs. Mills Science Time. Today we're going to take a look at properties of air, part one, because there's many things to talk about with air and I can't fit it all into just one video, so I need a couple. Anyways, and again, as always, feel free to check out the Stevenstein Teaching and Learning Journey website, where there's lots of activities there as well, and I try and add as many as I can. I'll keep adding. So, air, right? Um, Amazing. Uh, you think you know a lot about air and about gases, and then you kind of really have to just take a moment and kind of go, wow, air and gases are amazing. Okay, so we know that they're in the states of matter. Gas has particles that are very, very far apart, and we're going to take a look at just the fact that air has properties. So and gases have properties, so they are different than liquids and solids in many ways. So the first one we're going to talk about today is the property that air air takes up space. And you think sometimes that air is just nothing. It's just, oh, there's just air here. But it actually does take up space. Okay? And this is a cool little experiment you can do at home, anywhere. I encourage using the bathtub for this one because the idea of air taking up space is actually really fun. And we can think about it as being bubbles. Okay, so sorry, I just going to adjust my camera here so you can see this a bit better. So what I'm going to do is I have a beaker with a bunch of water in it, and I also have another smaller beaker that I'm going to put a piece of tape on the bottom of, and I'm going to take a Kleenex and crumple it all up, and I'm going to stick it in the bottom of this. It doesn't have to be right at the bottom. It's about halfway up. The Kleenex fits in there. Okay, the trick is not to let the Kleenex go over the edge at the top. So if I were to take this beaker and put it upside down in this container of water, would the Kleenex get wet, is the question. So take a moment and make a prediction. Do you think if I put this container into the container of water upside down with a Kleenex in it, will the Kleenex get wet? Okay, well, I hope you made your prediction, and let's see what happens. So, in it goes. Okay. We'll leave it there for a moment. I don't know if you can see very well, but most of the time when I show this to my class, they can't see either, but they're excited to find out what happens to this Kleenex. So let's take a look. We're going to bring that Kleenex out, and it's as dry as it was when it went in. So what happened? Well, what was in this container that kept the Kleenex from getting wet? Well, it was surrounded by air. So air does take up space. Air was inside this container, and when I put it in upside down, the air did not let the water go in because air takes up space and it fills the container. And even though we think this container looks empty, it's actually full of air, which is cool. So you can say to your parents or your friends, hey, is my glass half empty or half full? You can say it's always full. It's either full of air, full of liquid, or full of something else, but it's always full. Anyways, I like this one. Simple, easy, air takes up space. Okay, now we know that. Now the second property we're going to look at today is that air has mass. Okay, so what does that mean? Well, it means that air weighs something. Okay, it has mass. There's particles there, and if you weigh them, they will have a weight. They actually weigh something, and this is extremely important to know when you are learning about flight, especially, that weight actually, has mass to it, and the other time is really good to understand the whole idea of air having mass is just even when you're moving through air, you can feel it pushing against you, and it causes air resistance. Okay, it pushes back on you. So that's another way you can tell that air is there and it has mass. So what I do for this one is I will take a scale, and I like teaching my students how to use these scales because they're really fun to use. I'm just going to see if it's zeroed there now. Not quite. So we're just going to play around with this to get it so that the line here, the 0 line, lines up with the line on the scale. There we go. It's perfect now. Okay, so I'm going to take this balloon and I'm going to weigh it just as it is, empty. Okay, so when I look at it here now, the balance has moved, so I can actually I'll use this small. This is a small thing, so you would use the smallest measurer, the smallest weight, and move it until it lines up, and that means it has found the weight. So it's not quite there yet. There we go. So it looks like it's 1.9 grams. Okay, so we're going to say the empty balloon is 1.9 grams. Okay, so now we get to fill the balloon. I'm going to fill it pretty good here. Hopefully not pop it. Don't really like when that happens. Now, how do you get a balloon to stay on a scale? Well, I like to use the property of static electricity to get it to hold on there. Okay. So already we can see, oh, I better go around the other side. I'm going to knock the balloon off. Ooh. We can already see that the scale moved slightly. Now, air in a balloon is not going to weigh a lot. Ooh, I'm attracting it because I must be charged as well now. Okay, a little bit more. Not quite that much, I don't think. We'll just wait and see if it balances. And we're closer now, and we have it. So the balloon filled with air weighs 2.2 grams. Balloon plus air is 2.2 grams. So if it weighs more, that means that the air weighs something. There's air in there now, and it must have mass. So if we subtracted these two, 2.2 subtract 1.9 gives us an air total of 0.3 grams. So now we've proved that air takes up space and that air has mass. So I hope you enjoyed learning about air today, and tune in again next time where we look at some more cool properties of air. Have a good day.